Hello friends, in this video we are going to see a practical voltage source and how it is different than that of an ideal voltage source. So let's take a simple circuit. So the heading is practical voltage source. So it's a voltage source along with a small resistance connected in series, which is forming a practical voltage source. So this part is a practical voltage source. Now this source I am going to connect to a load resistance. Now again circuit is closed. Current IL will flow through the resistor, which will give rise to a voltage drop VL across load resistor in this polarity. Now because of this resistance which is in series with a load, some drop will be there, and that drop is given as, so voltage across this series resistor is nothing but IL multiplied by RSC, and the IL value will be given as voltage across the load resistor divided by its value. Now suppose I want to plot the graph of IL and VL. So VL versus IL, which I can say a VI characteristic of practical voltage source. Had it been given an ideal voltage source, it will be simply a constant value determined by this V. But now because of the load resistance and the resistance connected in series with this voltage source, the voltage won't be fixed. It will be a drooping in this form, meaning depend upon the value of this RSC, I will have a drop IL multiplied by RSC. So suppose I were to write a simple equation, I can say voltage across the load resistor will be equal to V minus IL RSC. So depend upon the value of this RSC and IL, I will have some value of voltage will be dropped across this series resistor. Because of that, I cannot say VL will be same as V, but it will be V minus IL RSC. So there is a small difference between ideal voltage source and a practical voltage source, and that difference is this series resistor. So ideally this RSC should be 0, so that I can say VL is same as V. But practically it is not possible, because every voltage source or every battery will have small series resistor connected in series with a voltage source. So it is very difficult to avoid this RSC. Practically this RSC is a small value, but it will always be there, but ideally it should be 0. So henceforth, whenever we solve a problem of a source transformation, we will always deal with a practical voltage source and try to convert that into a current source. that we will see in subsequent videos. Thank you.